Welcome to the video. Today we are going to solve another Math Olympiad problem. So the problem goes like this. How many 3-digit numbers are there where middle digit is the average of the other two? So, uh, we have to identify all those 3-digit numbers, and there are two ways to approach this, and we'll look at both of them today. Okay, let's get into it. So, in one method, let's assume that there are these 3-digit number A, B, and C. Now we have to find a digit. Here we have to find all the 3-digit numbers where this B is an average of these two. So we can focus on B first. So what values can B take? Can it take the value of 0? If it takes the value of 0, then A and C, they both must be 0, which is not possible. Otherwise, it will all be 0, 0, 0. So it cannot take the value of 0. Next, it can take the value of 1. The average will be, the A and C both can be 1, and the average will be 1. It can take the value of 2, 3, 4, 5, 6, 7, 8, and 9. As I said, it cannot take the value of 0. Now, in one approach, as I said, we have to only focus on these numbers. So now we have to find all the possible values of A and C for each of these digits. Okay. So for this one, we know that only 1 and 1 are possible. So there is one option. Here, we know that 2 and 2 are certainly possible. Then 1 and 3 are possible, and 3 and 1 are possible. Correct? So there is 3 that we can identify based on if the digits are equal or they are one off. There is one more possibility which I will come to at the end. For 3, again, we know that there is one possibility of equal values, one possibility with 4, 2, one possibility with like this, then the other possibility with 1, 5, and then there will be this 5. So there are 5 values. Again, for 4, there will be 2 more additions, so 7. With 5, there will be 2 more additions, so 9. Then it will decrease because now we are losing. So from 5, there are 4 you can go on the top and 4 you can go on the bottom. But for 6, you can go only 3 down and 3 on the top. So it will be again 7, then 5, then 3, and then 1. So these are the total number of 3-digit numbers that can be formed. Now okay, so let's sum this up first. So 1 and 9 will give us 10, 20, 25, 30, 25, and then this 35, and then this one will be 41. So we get 41 from here. Okay. Now, is that it? So what we have considered is if the A and C both are between 1 to 9, because for all of these, either we have taken the same digit or we have taken 1 or 2 offs. But we never took 0. So here 0 is not possible, but here 0 is possible. So for 1, if we take this as 0, this has to be 2, right? So 1 is possible. If for 2, if this is 0, then this has to be 4. For 3, if this is 0, this has to be 6. For 4, if this is 0, this has to be 8. For 5, this is 0. This has to be 10, which is not possible, right? So there are 4 additional combinations here. So which are 210, 420, 630, and 840. These are the additional 4. So we have to add 4 to this. So there are total 45 combinations which are possible. So this is our answer. Next, let's look at the other way of solving this, which is combinatorics. So here again, um, so we take A, B, C. This is A, this is B, this is C. Now here we have to we can ignore B and focus on finding the pairs of A and C. So we have to find combinations of A and C which will average out to be B and give us B. Okay? And you know that B has to be between 1 to 9. So we know this thing, that they have to be between 1 to 9, but we have to find all the combinations of A and C. Okay. So since it is averaging, for an average, the sum of A and C has to be even. So either it can be even plus even, and then when we average it out, we will get B, or it can be odd plus odd, and when we average it out, it will give us B. So there are these two ways. So what are the different ways A and C can be even? Okay. So for this is one, this is second way. So for one, for A to be even, A has to be between 2, 4, 6, 8. Correct? It cannot be 0 in any case. And C can be 0, 2, 4, 6, 8. So we can have a 0 in C. So a combination of these two, and when we average it out, we will find a value of B which is between 1 to 9. Correct? Then for 2, A can be 1, 3, 5, 7, and C can be 1, 3, 5, 7, 9. So we have 4 values from which A can be chosen and 5 values from which C can be chosen for first case. And we have 5 cases from which A can be chosen and 5 values from which C can be chosen for case 2. So how we are using combinatorics here is we need to, how many ways we can find pairs of A and C. For this case, we can have 4 into 5 pairs. And for this case, we can have 5 into 5 pairs of A and C. So in total, we will have 4 into 5 is First will give us 20 pairs and second will give us 25 pairs. 4 into 5 is 20, 5 into 5 is 25. So total we have is 45 pairs, and that 45 is our answer. Hope you like this video.